Hi, I'm Yana. Welcome to the very first episode of ACK Best Practices. Today we will try to deploy a microservice in around 10 minutes, and also we will explore Ingress with Alibaba Cloud. The first thing we want to do is to create a managed Kubernetes cluster using Terraform. Then we will deploy Piggy Metrics. Piggy Metrics is based on Spring Cloud. It's a very good use case for demonstrating microservices. And then we will deploy Ingress, and then we explore how to use logging and monitoring with Alibaba Cloud. Finally, we'll try some blue-green deployments and perform some stress tests. Alright, firstly, let's deploy a managed Kubernetes cluster. There are many ways to deploy the cluster. For example, you can deploy a cluster through Web UI, and also you can use a terminal for the deployment. And in this case, we will be using Terraform, which is very popular. So there are several options for Kubernetes clusters. They are serverless, managed, and also dedicated. What are the differences? For the serverless, that means you don't need to take care of the master and the worker nodes. The only thing you need to focus on is the deployment. And for managed, you have more access to the worker nodes. You can define the specification, for example. You also have access directly to the worker node machine. And for dedicated, you will also have control of the master node. So they differ in management levels, and then you have to decide which one is the best case for you. And for our use case, we will be using a managed Kubernetes cluster, which is very popular. So to create such a cluster, we need to do some definitions. Firstly, we will define AliCloud. Here you will find the access key and also the associated secret. For this part, we recommend to use a RAM user, and then you assign the privileges instead of using your root account. And for this example, we will be using EU West 1, which is the UK region. The second thing we want to do is to create a VPC. And in this case, we will call it VPC UK K8S. And also you will define the CIDR range. To define the CIDR and also to make sure it's not conflicting with the pod CIDR range, please take a look of the CIDR planning guide. And we will later define a vSwitch within the VPC. And lastly, we define a key pair for the cluster to access to the machines. You also can define a password, but generally key pairs are recommended. Now, here we come to the real part, to define the managed Kubernetes cluster. And we can assign the size of the machine and also the storage types. More importantly, we define a CIDR range for both the pod and also the service. And the next thing we need to do is to init and apply. For this, I already have initted the Terraform, and what we have to do is to type Terraform apply. And then we have to wait for a couple of minutes for the resources to be deployed. Well, the title said to deploy a microservice in around 10 minutes or less. Well, to make the magic happen, I did something early. So here we have a cluster already deployed, and we can take a look of that. So we can move on to the next step. So here is a cluster I have already deployed. It's already running, and we can take a look of the details. It's also important for you to gain the access for this cluster. And here you will find the essential settings for the Kubernetes control. And we can copy that, and then we will start a new window and we can edit the file. It's here. And we copy and paste the configurations. Now we should have the access to that cluster. Piggy Metrics is very popular. It's a microservice dealing personal finances. Piggy Metrics itself is very interesting. It deals with microservices, but it's defined using Docker Compose. And what we will be doing is to convert this into Kubernetes. Piggy Metrics uses Docker Compose for definitions, and we need to convert these into Kubernetes definitions. And for this, we will need to use Compose, and for the deployment, we will be using Helm. To convert these, we also need to modify the Docker Compose files because they are incompatible fields. And I have done this previously. And also there are some other things need to fix. For example, the MongoDB ports. So after we have done this, we will export some variables. So let's move to the directory so we can have a look of the application itself. So here I have created a sample which contains all the modified files we needed, and we can export all the variables, and then we use Compose to convert the files will be generated into a directory. Then you also need to install with Helm, and before that we will create a namespace so that we don't install everything into default, which will make a mess. And that's the content for the namespace, and we can create it. I have already put it there so we can run the command directly. And you can see we have successfully created a namespace, meaning we have the correct configurations too. Now we have the namespace and also everything ready, and we can do the deployment. You just need a single line. As you can see, it's really quick. Sometimes when you are using Helm, you may have this problem, which is a version mismatch for the client and also the server side. You have to uninstall or unlink the current Helm version and install the specific Helm version to match with the server. And then we can take a look from the console. The application should be there. We check the deployment. and remember to select the right namespace. And we can see they're all up and running. Then we can take a look of the service. Here we can see all the services are also up and running, and the gateway is the entrance for accessing the service. So let's go and take a look. Brilliant, it's up and running and it's working. Now we can try to create an account and give it a try to see if it's really working. Let's create an account called Rich and register. Good. And Rich, let's make some numbers for Mr. Rich. Let's say he has some rent for $2,000 per month, and add some salary if he works at all, maybe another 3,500 for salary. And we also can create some expenses, maybe 70 for fuel, and some electric bills, electricity, electricity. View. And some food, maybe 400 or 500 for food. And then we save the changes, and you can see there are very good diagrams created. Now we have our application ready. Then let's look at Ingress. Ingress is very flexible, and also it's very powerful for defining routings. We will deploy an Ingress for our Big Metrics application. To do this, we will go back to our script, and let's take a look of Ingress. Here I have a sample deployment. Here I have an Ingress definition. It's really simple. It's just a thin wrapper around the Metrics application. And let's remember to deploy it into the same namespace. I have already created a file. So let's start the deployment. Let's move to Ingress. Enter sample, and it's already there. And we can create the Ingress using kubecontrol. Okay, we see that it's being created, and we also can query that using kubecontrol. You can see the address not generated yet. It will take a while, maybe around 30 seconds or so. You also can find the Ingress from the web console. We can refresh. And right, the endpoint has been generated. We should have the same results from the command line. Yes, The IP address is there. Next we have to do is to bind the domain name to the Ingress IP address. For local testing, you can change the hosts, or we can change a real name, real DNS. And for this, I will copy the endpoint, and then I will use the DNS service to change the CNAME. Let's use this one. We set the peaking metrics, then we point it to the Ingress. The refresh will take several minutes, and for this, we will also modify the local host so it will become effective immediately. Okay, then we can save it. Now it should be working. Let's try. Yes. We have created the user reach, and we will use the same password as before. As you can see, it's all working, and we also can check the traffic. Now we have our app running and also Ingress as a thin layer as a routing. Then we also have set up DNS to point to Ingress. The log service has a very good integration with Ingress for monitoring and also logging. Next, let's use log service for the cluster. We also can use it for monitoring the Ingress traffic. The log service can be installed during the creation of the Kubernetes cluster if you are using the web console. For us, we use Terraform, and we will have to install it manually. Fortunately, it's not very difficult. It only takes one line of code. But beware, there are some parameters you will need to fill in. And let's copy and paste and do some changes. The first parameter we will need is the cluster ID. You can find this from the web console. This is the cluster we are using, and we will copy paste here, and then next we will find the user ID for the accounts. You can find your account ID from the security settings. This is my account ID, and I will copy and paste to replace this. Then the region ID, it's EU West 1. Okay, let's go to terminal and try that. It only takes a little bit time to install. Now we can see the installation has been successful, and we can apply. Then we will log the Ingress traffic. There's a template pre-built. You don't need to modify it, and we will use kube control again to create it. When we create the log component, in log service there will be a project created which associates with the cluster name. When we create the log controller in log service, there will be a project associated with the Kubernetes cluster ID. Let's take a look. Here we can see the project name contains the Kubernetes cluster ID. We also have configured Nginx Ingress. It also shows here. Then we can use the dashboard for Ingress. You can see there are some pre-built templates. Let's try one. Because our service is really new and there was not much traffic generated, but we still can take a look, and probably we can refresh and we can refresh and manually generate some traffic. There are several dashboards, and this is the access center. Gives you an overview of the access distribution. You can see the distribution from which country, and if in China, which region. And you can see the PV and also UV rates. There are some other metrics you can take a deeper look. You can see the primary traffic are all from the UK, because it's a very new service and only I visited it. Let's generate some traffic, so make the charts more pretty. To generate the traffic, I'll be using a tool called PTS, Performance Testing Service. PTS is available from Alibaba Cloud Domestic China portal. You can use any other stress testing. It's essentially the same. I have already created one test scenario. Let's take a look. It will only access to the URL, and the peak request per second, it's set to 200. and we will test it for 1 minute. And let's start the testing. Execute now. While the testing is running, we can go to Ingress Access Center, and we can check the accessing almost in real time. It also can auto refresh in 15 seconds interval. Remember, previously we only had access from the UK. Now there's a China access, because that's where the stress testing service is located. Now we have over 2,000 views. The stress testing has ended. We can stop refreshing. Ingress also have other panels you can check. These dashboards for Ingress can also be found from the project details. And let's switch back to the details. And for these numbers, each of the panel, you also can create an alert. For example, here you can set a demo alert, select a chart, and send some intervals and a trigger condition. That's just made it up 50. And then you can use different channels. You can receive an email, or if you use DingTalk, it's a real-time messaging tool. There will be a bot. There will be a bot to send you messages or notifications. Next, we will try blue-green deployment. And to do this, we will create another app, which is basically an Nginx, and we will deploy it using kubecontrol. And remember to deploy it to the same namespace as Piggymetrics. Alright, it's been created and we can take a look. It's been named as old Nginx. We should find it in the web console. Go to PM. Old Nginx. Yes, it's here. Now let's modify the ingress. We can edit the YAML file, and we'll add this annotation to split the traffic, 60% to gateway and 40% to old Nginx. And we add this as another backend. Now we are done with the YAML and we can click update. We'll find that now the URL being pointed to two endpoints. Using the ingress, we can see sometimes the traffic being pointed to picking metrics, sometimes it's being pointed to Nginx. We also can monitor the blue-green deployment. Let's do another round of stress testing. Execute now. Now the stress testing is running, and we can go back to here to monitor. The services will be explored automatically. You can find Nginx and the gateway. It takes some time to update. Stress testing is finished. We can stop the refresh and do some comparisons. It's useful when you have a new version and you want to deploy it, and you can have some testing samples to compare with the original service. As the lead two are very different, so you see the charts are very dramatic. Let's have a recap. Today we have created and managed the Kubernetes cluster using Terraform. Then we deployed picking metrics, and we configured the ingress and tried logging and monitoring using log service. And we just did a blue-green deployment and used stress testing. I hope this session is useful, and thanks for watching. Bye-bye.